Okay, so in this video we're going to have a look at solving quadratic equations by factorising. So this topic here obviously applies to both of the exam tiers, whether you're doing foundation or higher, although towards the latter end of the video here we are going to look at higher only questions, but I will say at which point it swaps to higher only questions, okay? So throughout this video we're going to be looking at obviously factorising. Now I'm going to do a little bit of explanation on factorising here, but I will obviously assume that you already have a good knowledge of that factorising there, and if you don't, I'll link the two videos in the description. So I'll put in factorising quadratics in the description and also factorising harder quadratics for some of the later ones that we're going to have a look at the end. But here we go, we're going to have a look at this one to start with. So grab a piece of paper, grab a pen, make some notes, and we're going to have a look at this question. So when it comes to solving a quadratic, the way to solve it is we have to factorise it, and we can only factorise it, and we'll discuss this a little bit more, when it is equal to 0. So sometimes they won't be equal to 0, but particularly in the foundation level style questions they're always going to be equal to 0 here, and if they're not, we'll have a look at how to obviously just rearrange them slightly in a later question here. But when it comes to this here, all we're going to do is we're going to have a look at that quadratic there. So we've got x squared plus 7x plus 12. Now when we're factorising one of these, they go into a double bracket. And all we need to do is have a look at this number at the end, which is 12, and we have a look at what numbers multiply to make 12. So we could have 1 and 12. And again, I'm not going to talk about this too much because I'm going to link the description for factorising quadratics, but we can have 6 and 2. And we can have 3 and 4. So we just need to figure out what combination of numbers are going to go into our double bracket. So we'll put our double bracket here. It's all equal to 0. And we've got an x at the start of both brackets. So obviously we're looking at that number in the middle there, the coefficient of x, which is positive 7. So the two numbers that are multiplied to make 12 and also add to make that positive 7 are our 3 and our 4. Okay, so we're going to put 3 and 4 in our bracket, and that would be plus 3 and plus 4. There we go. Now in terms of obviously our solutions here, now you don't really need to know this for this question in particular, but if this was a quadratic equation, a line equation, sorry, it would relate to a quadratic curve, okay? Now I'm going to draw what this would look like. It looks something like this, okay? There we go, not to scale there, but it looks something like that. Now when we are looking at the solutions here, we are looking for essentially where this curve crosses through the x-axis, and that's what equal to 0 is representing there, and it's in a kind of very simple level. Equal to 0 kind of means a ground level. It means where y is equal to 0, and if you think about the y-axis, the y coordinate just here, we've got y equals 0 just down there. So we are having a look at, on this graph, where does the quadratic curve cross through the x-axis when y is equal to 0. Now there's a little trick with these brackets, but in terms of obviously explaining how we go about getting our solutions here, we just say, okay, well when does this bracket here, x plus 3 equal 0? And if we write that out, when does x plus 3 equal 0? And if we take away 3 from both sides to solve that, we get x has to be equal to negative 3. And if we do that for the other one as well, so if we do that for this one just here, we say, okay, well when does x plus 4 equal 0? And again, if we solve that and take away 4 from both sides, we get x has got to be equal to negative 4. So there we go. If I label that on the graph here, we've got minus 3 and we've got minus 4, and that's how I knew what the graph would look like. But there we go, there's our two solutions. X is negative 3 and x is negative 4. But if you have a look at the bits in the brackets there, obviously we've got a plus 3 in the bracket, and our solution ended up being negative 3. And on the flip side, on the other one, we had plus 4 in the bracket, and our solution ended up being negative 4. So obviously it's important to know how to do this little process here, setting them both equal to 0 and solving it for some of the harder ones. But in terms of just getting through these questions nice and quick, once you've factorised it, all you have to do is flip the symbol in the bracket there. And we're going to have a look at a couple of others where maybe there's a negative in the bracket or two negatives or something like that. But that's all you've got to do is just flip the symbol. So there we go, there's our two solutions. X is equal to negative 3 and x is equal to negative 4. So you will notice that in these questions we'll tend to get two solutions, unless obviously the two solutions are maybe the same, which can happen as well, but we're always going to get two solutions here, and in this case it was negative 3 and negative 4. Let's have a look at another one then. Okay, so this question here, we've got positive 16 at the end there. It's still equal to 0. Always check that first. We've got to make sure it equals 0. So we can actually just go about factorising this straight away. So for 16, we can have 1 and 16. We could have 2 and 8. Or we could have 4 and 4. Now the number we're trying to make in the middle here this time is negative 8. And if we have a look at our numbers there, 1 and 16 can't make negative 8. Neither can 2 and 8, but 4 and 4 we can make negative 8. We can actually do that by doing negative 4 and negative 4. So in our bracket here we'll have x minus 4, x minus 4. There we go, and that is all equal to 0. Now, as I mentioned, look, if you have a look at the brackets this time, we've got -4 in both our brackets here. So if we do go about that bit of the process, and again, if we just flip the sign, obviously, I'm going to set it equal to 0 and solve it. X minus 4 equals 0, add 4 to both sides, and we get x equals 4 as our solution. Now we're going to get that as well for the other bracket there. So that means we've only got the one solution, that's that x is equal to 4. Okay, and in terms of what that means in terms of the graph, and again, you only really need to know this if you are progressing with your solving quadratic equations, you know, up to the higher level and the grade 7 and beyond topics where we're looking at sketching quadratics and stuff like that. But in terms of what this would look like, we would have a quadratic, and if I try and draw it as best I can, it would just touch the x-axis at that one point. There we go, and go back up again. I just kind of missed that there. Let's just get rid of that and draw my little line in there. There we go. But essentially, that's what this graph would look like. We'd have a solution of 4 just there, but it wouldn't actually cross through the x-axis, and we'd just have the one solution there where it touches it and goes back up. Essentially, the x-axis is a tangent there at the bottom. But there we go. That is obviously how we would go about solving it. You don't actually need to draw the sketch here, but I just think it's important when you're learning this to understand what it actually means and how it relates to the graph. But there we go. There's our solution, x equals 4. Let's have a look at one more before we have a go. Okay, so for our last question here, before you have a go, hopefully you notice just by looking at it, when it says x squared minus 2x equals 15, this question here doesn't equal 0, or it doesn't equal 0 yet. So before we can actually factorise this and solve it, we need to move that 15 to the other side. That's easy enough, we just have to subtract 15 from both sides, and that will give us equals 0 on the right there. And if we do that, and I'll slot the 15 right at the end, we get x squared minus 2x minus 15 is equal to 0. There we go. And it's worth noting at this point as well, to be fair, that 2x could have been put on the other side. It could have been 15 plus 2x over here, and we had to subtract the 2x as well. Now for the purpose of obviously this question, we're just going to have a look at obviously a nice simple one, but to be fair, we could put as many pieces as we want on the right hand side. It always needs rearranging to make it equal 0. But we'll get rid of that, obviously, because the 2x was on the left, and now we can just go about factorising it and solving it as normal. So for 15, we can have 1 and 15, or 3 and 5, and there are only options for this one, and we're trying to make -2 there, so we're going to have to use 3 and 5. So we'll want +3, take away 5, and that'll give us -2 in the middle there. So if we put that into a double bracket, we get x, and what do we say, +3, and x -5, or x take away 5. There we go, that's equal to 0. Always leave that equals 0 in there. Don't forget it is an equation that we're solving, so we don't just want to get rid of that. And then we can get our two solutions. I'm just going to apply the little trick this time. It's +3 in the bracket, so that's going to flip to -3, so x equals -3. And for the second one there, we have -5 in the bracket, and again if we flip the sign for that, we get x equals +5. And there we go, there's our two solutions. X is -3 and x is +5. And again, just very briefly, in terms of what the graph would look like there, it would go through a negative and a positive solution. I'm not going to do it to scale, but it would look something like that, that would allow it to go through a negative over here at -3 and a positive over here at 5. And that's all that we're actually working out. That's what we're solving, these two solutions here. I'm just thinking about what the graph would look like. So I've got a couple of questions for you to have a go at. Obviously, the main priority here is actually getting to these solutions. X is -3, x is 5. But if you want to do a little bit of an extension on top of that, you could always think about drawing the quadratic curve as well, and actually thinking about what it would look like. And I think that's a nice little extension for this topic as well. But I'm not going to go over the answers for the curves on the next part. I'm just going to go through the solutions. So here's a couple of questions for you to have a go at. Okay, so here's 4 questions, so pause the video there, have a go at solving all of these, and then we'll go over the answers in a sec. Okay, so for this first one then, 14. Now the two numbers that times to make 14, and we'll add to make 9 here, will be 2 and 7. So if we put them in the brackets, it's all positive, so we get x plus 2 and x plus 7 that are equal to 0. And then if we flip the signs there, we get x has to be equal to -2, and x has to be equal to -7. I don't know what order you've gone in, but I'm just going to go down to this 12 here. So I always tend to write down all the factors, unless it's all pluses there, I do tend to write them all down. So we have 1 and 12, 2 and 6, 3 and 4, we've got -7 in the middle, so we want -3 and -4. So we have x minus 3 and x minus 4 that are all equal to 0. There we go. And flipping the signs there, we get x is equal to +3. I was going to write 4 then. Let's actually do them in the same order. X is equal to +3 for that one, and x is equal to +4 for the one on the right there. Okay, up to the top right then, we've got 35 at the end. So we can either have 1 and 35, or we could have 5 and 7. And we've got plus 2 in the middle there. So we're going to want positive 7, take away 5. So x plus 7 in one bracket and x minus 5 in the other. And then flipping the signs there, we'll get x is equal to negative 7 and x is equal to positive 5. Now for the last one, we've got to get it equal to 0, so we need to minus 24 from both sides. So if we rewrite this, we get x squared minus 5x minus 24, that's equal to 0. And then we can look at our two factors there. So for 24, we could have 4 and 6. So there is 2 and 12 as well. 3 and 8. So I can already spot it's 3 and 8. So I'm not going to write them all down. We could have had 1 and 24. But there we go. We want negative 5. So we're going to need positive 3 and negative 8. So we've got x plus 3, x minus 8, that equal to 0. And in our two solutions there, we get x is equal to negative 3 and x is equal to positive 8. There we go, and there's also all our solutions. That's how you solve a quadratic equation. Now we're going to have a look at something which is just ever so slightly different, okay, and we'll have a look at that one now. Okay, so for this question here, we've got something a little bit more unique in there. Now, these aren't necessarily harder, they're not necessarily easier, they're just a little bit different. Now, if you notice what's different, there's no number at the end of the quadratic. It's x squared minus 3x, and we don't have any numbers there. Obviously, it's already equal to 0, so we can definitely solve it as it is, but there's no number. Now, if there is no number at the end of a quadratic, that just gives you the one big hint that it doesn't factorise into a double bracket, but it factorises into a single bracket. And if you have a look at those two pieces there, we've got an x squared and a 3x. Now they both have an x in. So essentially we can take x out of the bracket and just factorise it into a single bracket. And inside the bracket there we would get x minus 3, and that is all equal to 0. Okay, so nice and simple, to be fair. It's obviously easier when you factorise into a single bracket, in my personal opinion, but obviously this is one that tends to throw people, and they kind of sit looking at it thinking, how on earth is that going to go into a double bracket? Well, if there's no number at the end, it goes into a single bracket. And we treat this in exactly the same way as we did before. What we have is this bracket here, which again, if we set it equal to 0, x minus 3 equals 0. Flip the sign or add 3 to the other side, we get x equals 3. But for the one on the left here, again, we're going to set it equal to 0, but there's no number with it. So all we get is x equals 0, and there's nothing there to solve. It just tells us our solution, x equals 0. So if we ever get that solution, or this situation where there is an x or a single bracket, that piece on the outside there is just always equal to 0. So we get our two solutions, x is 0 and x is 3. But again, thinking about what this would look like, if we have a solution that is 0, it just means that the curve crosses through or passes through the origin. So it would go through something like that when we get 0 and 3, and that's what this particular curve would look like with our two solutions there. So we'll have a look at another one just like this, then a couple for you to have a go at. So let's have a look at our next one. Okay, so this one here has obviously a 2x squared, but in terms of obviously looking at it, it's equal to 0, so that's fine, but again, there's no number at the end. So it has to factorise into a single bracket, and if we look at it this time, we've got 2 and 5, or no numbers going to 2 and 5, but we do have an x in both of them, so we can take an x out again. So if we take the x out, we get in brackets here 2x plus 5, that's equal to 0. There we go. Now again, our first solution's nice and easy. We've got the one on the outside, that's x equals 0, so that's nice and simple. But this one here, and this is where it's going to lead into the higher questions, if we have a piece like this in a bracket, there is a little trick to getting the solution here, but we just need to actually write it like we did before. So we're going to set it equal to 0. So we get 2x plus 5 is equal to 0. And we have a relatively simple equation to solve there. We just need to minus 5 from both sides, but now we get 2x equals minus 5, and obviously we want to know what x equals, so we have to then divide it by 2. So if we divide it by 2, and if you've got a calculator, then you can type it into a calculator, but if this is non-calculator, we're just going to put the 2 underneath the 5, and you get minus 5 over 2. And negative 5 over 2, if you want, you can write it as a decimal. It's always fine to leave it as a fraction unless it's specifically asked for a decimal, but that is going to be negative 2.5. So x equals negative 2.5, and we just get a decimal answer instead, and this can happen as well. And this is where it really leads into the higher questions, but this is not, obviously, I hope to think that this is quite simple once you know this little process here of setting it equal to 0 and actually just going about solving it, and it's actually relatively okay just to go about doing that. And all it means in terms of our quadratic is one of our solutions is obviously a decimal, and as it passes through the axes, let's have a look, we've got negative 2.5, there we go, so it would just look something like this, and it would just end up going through a decimal there, minus 2.5. And that's absolutely fine as well. And even though this would be a pretty difficult question to ever appear on a foundation paper, this is obviously not too much of an extension from what we did. I think it's just important to know obviously how to factorise it, and obviously then linking that to solving as well. But there we go, we get our two solutions, x is 0 and x is negative 2.5, and we're going to have a go at a couple of these to finish these ones off. Okay, so here's two questions, so pause the video there, have a go at these, and we'll go over the answers in a sec. Okay, so for the first one then, now if we take x out of this, let's have a look. We get x brackets, and we get 2x minus 3 that equals 0. And again, if we get our two solutions here, we've got x is 0 for the one on the outside, and the one in the bracket there. If we set that equal to 0, we get 2x minus 3 equals 0. Adding the 3 to the other side, 2x equals 3. Dividing by 2, x is equal to 3 over 2, which is also, could be written as 1.5 as well, but there we go. I'm just going to leave it as 3 over 2, and there's our first one. On to our second one here, let's have a look at that. We've got 3x squared plus 7x equals 0. So if we factorise x out again, we get x brackets 3x plus 7 that's equal to 0. And then again, we get our x equals 0 for the first one. And the second one, we'll solve it here. We get 3x plus 7 equals 0. Minus 7 from both sides. 3x equals minus 7, and then dividing by 3, we get x is equal to negative 7 over 3. So not a very nice looking solution there, but there we go, just leaving that as a fraction. Again, that would give us a recurring decimal if we did write it as a decimal, so I just prefer leave it as a fraction when we get that scenario. But again, if you do look at these, obviously there is a little bit of a trick with the brackets again. You still flip this number here, so we still get minus 7. It's just that we divide it by this number here, divide it by 3. The same for the first one. Look, we flipped this to become positive 3, but then just divided it by 2. And that was just our little extra step when we do have these coefficients of x there in the brackets. But there we go. That is what I would say is the end of the questions in terms of anyone that is doing the foundation level. We're just going to have a look at a couple of questions now on the higher tier style questions where we have coefficients of x squared that are greater than 0, and have a look at a couple of those now. So here they are. Okay, so this question here, we've got a 2x squared. So again, I'll link in the description the video for obviously factorising harder quadratics. So I will explain them a little bit, but I won't go into as much depth as I did in that video. So do check that one out if you're not sure on how to factorise these. Now, in terms of a 2x squared, that means in one of our brackets here, we're going to have a 2x when we're factorising it. So if I set the brackets up, we've got a 2x and an x. It's all equal to 0, and we just need to figure out where the numbers go. Now, if we've got a 1 at the end, our only factors can be 1 and 1, but one of them is going to be doubled. Okay, obviously when we expand our double bracket here, we've got a 2x, and it's going to double that 1 in the other bracket. So as they're both 1s, we know they're both going to be 1s here. We just need to figure out the symbols. Now we want minus 1x, or minus 1 in the middle. So in order to make minus 1, we're going to want positive 1 take away 2. So as this one over here is going to be doubled, we'll make that one become our minus 2, and this will be our positive 1 here. And obviously you can go about expanding that just to check that it matches, but there we go, that is going to match. We're going to get plus 1 on this expansion here, plus 1x, and we're going to get minus 2x when we expand that one there, and that'll give us minus 1 in total. So in terms of obviously getting our solutions here, it's very similar to what we just looked at. If we just set them both equal to 0, this one here is just going to become x equals 1. Obviously we haven't got a coefficient there, and this one here, we're going to flip the sign, so x is going to equal minus 1, but then we're going to divide it by the 2. So minus 1 over 2, or minus a half. And there's our two solutions, x is minus a half, and x equals 1. And again, you could obviously draw your sketch of your quadratic there. Just thinking about what it looks like, it's going to go through 1 and minus a half. And you could draw that in, there we go, 1 and minus a half. And that's where our two solutions are. Okay, one more to have a look at then before you have a go. So for this one here, we've got 3x squared at the start. So for 3x squared, we're going to need a 3x in the bracket. So for 3x in the bracket and an x in the other one, and let's have a look at our factors. So for 6, we've got two options, 1 and 6, or 2 and 3, and we're trying to make 11. In the middle, obviously, negative 11 there, let's just highlight that. And obviously one of these numbers this time is going to be tripled or multiplied by 3, given that we have a 3x in one of the brackets. So if we have a look at our pairs, then how could we make 11? Well, we could double the 6, that'd make 12 and 1. We could make 11 out of that. but we're obviously tripling it, so that's not going to work. So it would be triple the 6 would be 18 and 1, or triple the 1 would be 3 and 6. So that's not going to work. So 1 and 6 is out of the question, so it must be 2 and 3. Now we can triple the 3, that would make 9. So we could have 9 and 2, that's going to work. So if we put the 3 over here, that's going to make 9. And the 2 over here, and in total that's going to make 11. Now we want to make negative 11, so we want minus 9 and minus 2. And that's going to make our negative 11 there. So there we go, obviously just a little bit of factorising there. Obviously don't forget to check the video out if that is throwing you at all. And we get our two solutions here. For the one on the right, we're going to get x is equal to positive 3 when we flip the sign. And this one on the left here, I'll do the full process. We get 3x minus 2 equals 0. Add the 2 over, and we get 3x equals 2. Divide by 3, and we get x equals 2 divided by 3, or 2/3 there. So there we go, there's our two solutions. We get a fractional answer there and a whole number there. And in terms of our quadratic, again, if we were to draw a little picture of this, let's just have a think. There we go, it looks something like that with our 2/3 and 3 as our two solutions there. So there we go, that is obviously how to solve some of these harder quadratics, and obviously so a lot of the time these are incorporated into bigger questions, or you might have to have formulated or created the equation yourself. But in terms of actually the skill-based process to actually solving these, that's how we go about them. So before we finish, I've got a couple of questions for you to have a go at, and they'll be our last two for the video. Okay, so here's your last two questions. So you've got two there to factorise and solve. So pause the video there, have a go, and go over the answers in a sec. Okay, so for this first one then, now we've got a 2x in the bracket along with another x. And there we go, our options are 1 and 9 or 3 and 3. And we're trying to make positive 3 in the middle. So one of them's going to double, so we can have 2 and 9, well that's not going to work, or 1 and 18, that's not going to work either, so we know it's going to have to be 3 and 3. Now as they're both the same, let's just put them both in the bracket. We just need to figure out the combination there. We're trying to make positive 3 in the middle. So if we have positive 6 by doubling this 3, and take away 3 over here, that's going to make positive 3 in the middle there. So there we go, we get our two solutions. We get x is equal to negative 3 on this side, and for this bracket here, we get x is equal to, and we're going to get positive 3, and then divide it by 2, so 3 over 2 or 1.5, and you can write it either way. But there's our two solutions, 3 over 2 or 1.5, and negative 3. And for our last one here, we've got a 3x squared, so that's going to be a 3x in the bracket again, and an x in the other one that equals 0. We've got 10 at the end, so we can have 1 and 10, or we could have 2 and 5, and remembering one of them's going to triple this time, and we're trying to make positive 17. They're all positive here, so that's quite nice. We don't have to worry about the symbols, but let's have a think. We're trying to triple 1, so if we could triple the 1, that'd make 3. So we could have 3 and 10 or 1 and 30, neither of those work, so it's going to have to be 2 and 5. We could triple the 5, that'd make 15, plus the 2, that's 17. So if we put the 5 over here, that triples that, and the 2 here, and there we go, that's our brackets obviously completed there. So for our solutions, the one on the left here, we get x is going to equal, flip the sign, negative 2 divided by the 3. And for this one on the right, x is going to equal negative 5, and there's our two solutions. Right, okay, there we go. So that is obviously how to solve quadratics, obviously bearing in mind that this tends to be incorporated into other topics where you have to use quadratics and then solve it as well. Primarily if you are thinking about obviously the higher GCSE and sort of where this goes. Something like quadratic simultaneous equations, where this comes in sort of part of the steps there, can be one of those sort of grade 9 topics where this sort of thing is involved here. But that is obviously how to go about factorising and solving a quadratic, and obviously getting your solutions correct and how to draw them as a sketch as well if you want to take it that far. But hopefully you found that useful and helpful. If you did, please like, please comment, please subscribe, and I'll see you for the next one.